I'm Giorgio Metta. I'm from the Italian Institute of Technology, a research institute based in Genoa, Italy, and I work on human robotics, and in particular I'm the coordinator of the ICAB project. Today I'm going to speak about the ICAB, Human Robotics Project developed the Italian Institute of Technology. So we thought about how do we use these new materials in the future robot design. And there are basically four main areas where we can concentrate our effort. The covers of the robot, that's easy. Actuators, so how to modify not the electrical motors that are not readily modifiable, but all the gears, all the levers, or the bearings that are not normally metal to be moved into polymer components. The frame structure of the robot can also be optimized, and the electronics. And I'm going to basically give ideas on how this can actually happen in the context of some of the work that we're doing at IIT. So we're working on this. So covers. One possibility, as I mentioned, is the integrated electronics, integrated wiring, or integrated pressure sensor. So the skin can be directly designed or etched into the plastic. There are now 3D printing machines that can print basically the PCB directly on plastic. So you can print a PCB on the cover of the robot in 3D. So you can do the skin will be there, temperature sensors, or anything else that is needed can be actually embedded. The wiring will be great because we'll reduce a lot the number of wiring and the complexity of building the robot. There's one complexity, one limitation if you wish. There's no tool to design these circuits directly in 3D at the moment. So all CAD is intrinsically 2D done for flat PCBs, so there's a lot of custom design to be done in order to do things in 3D. But there are examples. In this image, for instance, I show a fingertip where all the circuits, all the electrodes have been designed directly into the plastic that makes the fingertip. So there's nothing to be glued. It's a much better work. And actually, you can actually solder the ICs or any other component you're using for your electronics directly into this plastic. So a fully functional 3D PCB. Moving to the actuators. So the actuators are the parts of the robot that weighs the match. Highest density, and they make for 40% of the robot mass. And that's natural if you think it. I mean, the motor is typically magnets and metal. There are coils, and it's all high density materials. And then the transmission and the bearings are also typically in steel materials, so the highest possible density. Now for the motors, at the moment there's no that much work going on. The only thing we sort of were thinking that may happen is to modify basically to try to have a strong magnetic field in coils that are made of carbon-based conductors instead of the copper and the let's say rare earth magnets that are typically used now. The idea is not as strange as it may seem. There are Chinese companies that are working on that. Although most of these materials are actually found in China, I think China exports 98% of the rare earth magnets worldwide. It's still the case that they may not last forever, and so at a certain point, why not looking for alternatives? So one alternative is graphene-based materials, which are conductors, and it's very good conductor, in fact. And it may happen that the motor is actually built out of graphene-based material, but it's far from being ready. I mean, this is stuff that is happening in whatever, next 5 to 10 years. I mean, it's a long time. There's a lot to be done in that direction. The transmission is a lot better. I mean, if we manage to substitute the steel part with polymeric ones, then there may be up to 83% weight reduction in the transmission components. It will certainly be a game-changing technology for robotics, but maybe also aerospace, also automotive. The only thing we have to plan in this case is, or we need materials that are stronger. So polymers that are lightweight, but at the same time a lot stronger than what we have now. I mean, we've seen from the numbers that the current polymers are 5 times less strong than aluminum, and we need at least to get to that level if we want to be able to use them. And finally, the transmission is also a place where you see most of the local pressure in the mechanical structure. If you go and look at for instance, the motor shaft or at the gear output or at the interface of the teeth of a gear, I mean, there are a very high number. And so again, we need an increase in the polymeric materials of 3-4 times, so 3-4-fold increase in the maximum specific pressure at these components, which is, again, it's not available. One solution may be graphene, that's a possibility, or anyway polymers with fillers that can increase the mechanical properties of these materials. Because otherwise, building an entire robot in plastic right now, you build a robot that is weak, intrinsically weak, won't be able to lift anything. If you take the calculations, you cannot actually stand the interaction with the environment, so it's not doable entirely in plastic. There's something happening at the bearing level. We actually discover components, so ball bearings that are made entirely in polymers, and these are available commercially. So there's something that's happening in the direction of moving from metal to other materials. And this is something we actually started using in our new cost-effective platform. About the frame of the robot that I mentioned earlier, again, there are 2 strategies. One is that the frame of the robot can be smart, so you can have electronics embedded into it. The other thing is that there's a possibility of reducing the weight. As I said, from aluminum, there is a typical material that is used now on the iCab, to the polymers, it's 50%, 54% weight reduction. And this it would be good. And but there are drawbacks. If you use the materials we have now, you have to make a thicker frame because so you use more space because mechanical properties of the material are not the same as of metals. And also there's to be taken into account that if you molding the parts, there's a maximum thickness that you can actually use that is about 5 millimeters. So you cannot make very thick materials in frames for robots because there's a limit on the way you do it. But this may be done, and maybe it's a good way to do it, but it requires a completely new design approach. I mean, if you're assuming you have metal, you have these almost infinite possibilities with very strong materials. If you're going for polymers, it's completely new. It's a game changer in the sense that you have to design differently. Last but not least, the electronics. There, I mean, it's not the domain where you have most need for new materials. I mean, electronics certainly is providing new sensors, and those are made out of nanotechnology or micro machining. I mean, there's various strategies for obtaining sensors. For instance, in the domain of the tactile sensors, MEMS are useful for building tiny sensors that can measure shear forces, which is something we cannot do right now, or at least not on the iCab. And so those are promising because you may get more accurate sensors. So measuring shear forces may help detecting slippage if you manipulate an object. That's a possible application. For electronic in general, what can be done with new materials is shielding and heat dissipation. And so if you have a material like graphene that can actually go around a piece of electronics, it may shield the electronics from external disturbances, but also may avoid the electronics emitting into space. So it makes all the electromagnetic certification easier, and also the robot more robust because you will avoid crosstalks between sensors, electronics, etc. And heat dissipation is a concrete possibility because again, graphene is a material that conducts heat very well, and so it can be used for building smaller and more lightweight heat dissipation components, which are very useful. Depending on what you're doing, they're super useful. Like LEDs are very hot parts typically, and it's good if you bring their or improve heat dissipation. So LEDs for illumination. So if you want a robot to bring around its own self-illuminating devices, that can be the case. That's a possibility. But also for standard electronics, the power electronics emits quite a lot of heat, and reducing that is useful. So the next slide, I'm kind of joking now, but I think these are all ideas that may go into the direction of making the robots viable, because definitely bringing the cost down and making the robots simpler to build and making them more robust in the long term, simply because they're made of less parts and parts that cannot break that easily. It sort of goes along the same pathway that was followed by the mobile communication industry, making devices. They started from big devices, super expensive, ended up to small devices, super robust, super well integrated, that are basically also cheaper. Now, there are maybe two facts of that support this idea that robotics is becoming a bit more mainstream. One was Google, this article on Spectrum, on IEEE Spectrum, that says Google acquired 7 robot companies, wants big role in robotics. And it's interesting because Google spent about $2 billion for acquiring these companies. So it's a lot of money put into robotics. And the other article is a special report on The Economist titled Rise of the Robots. And the fact that The Economist is mentioned these, and together with also a list of possibly disappearing jobs, meaning that there may be a lot of jobs created by programming robots maybe, but a lot of jobs that may be disappearing because of the automation. That's also an interesting trend. I mean, something to be followed very closely. And the next slide is just the group of people working on these projects. So on the iCab, on the new iCab, on the cost-effective robot, it's about 70 people at IIT, and that's a large group, but we sort of doing the entire design chain, starting from the design of the mechanics, design of the electronics, construction of the robots, maintenance of the robots, not only our robots, also those we sold to other people. So we analyzed now quite completely the possible future developments of the iCab project. So in particular, we went through this idea that we may need to change the design of the robots in the future, and also how this may connect to the development of new materials, especially polymeric-based materials for these new developments. Simply, the current technology doesn't seem to be feasible and affordable enough for robotics to enter the household.